Hello friends, in the past video we have discussed about the bearing capacity of a single under-reamed pipe. In the present video we will discuss how to find the bearing capacity if we are having more than one under-reamed pipe. So as an example, let us see about the double under-reamed pipe. Okay, let us consider a pipe with two under-reamed sizes. Let us consider a pile and we are having two under-rim bulbs, and let us imagine that you are applying a load in downward direction, right? Imagine if you are applying a load like this, then what we discussed, the soil below the bulb will get compacted. That means from this bulb below of it until the second one, and similarly until the second one to the ground up to the tip of the pipe, the soil will get compacted and it will behave like a pile. That means up to this level, then we are having the pile with a diameter of capital D. After this entire part will behave it like a pile having a diameter capital DU. So that's why up to this level, let us consider the length of the pile. The length of the pile, it is L1. Then after this, consider the length of the pile is equal to L2. In the portion L1, what is the diameter of the pile? Capital D. In the portion L2, the diameter of the pile, it is like a diameter of the under-reamed bulb. What is the under-reamed bulb? D represented by V. So here, let us, how you find the ultimate capacity of a pile? That will be nothing but a QB into AB plus QS into AS, isn't it? And if you are coming for the QB, what is the end bearing resistance? So instead of D, the end bearing will exist throughout the diameter capital DU. So that's why QB is nothing but a C into NC, or else we can directly write it down as 9 into C. Whatever the area at the tip of the pile, that will be equal to, as it is a circular shape with diameter capital DU square. So this is what about the end bearing resistance. Then what about the frictional resistance? The frictional resistance in the portion L1, this will act in the original pile diameter having capital D like this. But after the length L1, your will behave like this. So here we have to consider it like over the length L1 and over the length L2. So total QS, that I can say it as a QS1 plus QS2. QS1, that means frictional resistance over a length L1. So over length L1, what about the QS1? Here instead of writing capital QS1, what I will do is that capital QS I will write down, that will be equal to QS1 into AS1 plus QS2 into AS2. What about QS1 over length of L1? That will be equal to alpha into C bar. In the part of length L1, we are having soil and the pile is in contact. That way, as we are having two different materials, alpha into C bar. What about AS1? That will be nothing but a pi into D. It is a circumference length into over length of L1. Similarly, over length L2. Over length L2. What about frictional resistance QS2? Here, the soil and soil is in contact. So if you see here, this is also a soil, this is also soil. As we are talking about only one material, alpha will be equal to 1. So it will be nothing but a simply C bar. What about circumference area? It is having some enlarged shape, having diameter capital DU. whatever the circumference length, pi into du over length of L2. Now if you sum it up, these are nothing but a frictional resistance. Now like this, in the similar way we can find out for any number of under-reamed files for bearing capacity. In the next video, we will solve some problems based on this under-reamed files. Thank you.